Okay. Okay, the session is being recorded, so sorry for not recording. So for those who would be listening to the recorded session, just a quick overview. We went through the course handout, the course objectives that students will be able to design an effective OO system given a problem. And then coming to the textbooks, so it is good to buy the textbooks, and reference book is for your enhanced knowledge, so you may buy it or you may not buy it. That is up to you. Let's move ahead. Uh, this slide is slightly more congested, and I'm trying to present the modular content of the structure. This modular content is already available in the course handout. The whole idea is to make you familiar as to what majority we are going to cover before mid-semester. So this particular slide is telling what will be conducting before the mid-semester. We'll have a complete overview of OOAD and the unified process. Now, this is what the target for today's lecture is. We'll cover the first introduction part. We'll have an overview of the unified process and in general OOAD. Then the subsequent lectures will focus on the various diagrams which can be drawn using the unified modeling language. So effectively, we'll be covering use case diagrams, use case text scenarios, domain models, swim lane and activity diagrams, state diagrams, system sequence diagram, operation contracts, and then in the next half of the course, which would be post mid-semester, we'll move to class diagrams and sequence diagrams. Right, so a bit of UML is there after the mid-semester as well. And then the rest of the pending lectures will focus on the design patterns. There are two set of design patterns that we'll be looking at. The first set is the grasp patterns. So there will be around 9 grasp patterns that we'll see, and the gang of 4 patterns. A total of 8 gang of 4 patterns are there in your course, and if the time permits, we'll take more gang of 4 patterns, because in total there are 23 gang of 4 patterns. So why not enhance and study as much as we can, right? So as per the course handout, these 8 are in your course, but whatever more we'll cover, we'll have that. Okay. A quick overview of how this course is going to proceed, right? So most of you might be aware of this. We're going to have this course in a flipped mode. So there is digital content which is created in the form of lectures, recorded lectures, and it is being uploaded on the eLearn portal. The idea is that you are requested to go through the digital content before you come to the class, right? So your class, that means an online lecture of this kind of a nature, is more or less a problem solving session or a tutorial, right? Since we are in the first session, in this particular session, I'll be touching upon the unified process model. So I would say I would be teaching the model, but from the subsequent sessions, it will be only problem solving. So I will tell you at the end of every session what are the sessions that what are the digital content or what are the recorded lectures that you need to go through before attending the next session. You are requested to go through those video lectures and come prepared for the class. In class, I'll take an overview of the content that you were expected to go through. So that overview will not be more than 15 to 20 minutes. Once that is done, then I will straight away start with the case study, right? And in that case study, we'll understand the case study and we will try to draw the model that we are looking at that time, right? So it is good when you come for this session, for this online lecture from the next time, get a pen and a paper with yourself so that during the class itself, you also draw the diagrams, and we'll find ways how we can share the diagrams with each other or through the chat, so that at least we are able to solve the problems in the class itself, right? And if you're attentive at that time, and if you're participating actively while doing those problem solvings, I think that will be more than enough for you to actually solve as many problems, right? So if you solve 2-3 problems here in this class, you will be able to solve n number of problems during the examination, right? So please be more attentive during the online lecture and participate as much as you can. Make yourself available during the online lectures and solve the problems along with me, so that we are all in the same pace. But for that, it is very important that you go through the recorded lectures beforehand, right? I understand everybody has challenges, and there is a lot of load that you might be having from your other engagements that you have, your as per your job, employment, etc., etc. But then it is important for you to dedicate the required time for every course. Okay, with this I move ahead. So I hope the flipped model of learning is clear to everybody. And coming to the number of online sessions we'll have. So we'll have total 22 hours of online sessions, and this will be divided roughly into 11 sessions of 2 hours each, right? And again roughly divided, so we would have 6 sessions before mid semester and 5 sessions of 2 hours each after mid semester, right? So this is what is planned, and if there are any changes or deviations from this, you will be notified through the eLearn portal. Okay, let's move to the course plan. So this is something I briefed you about, 11 sessions of 2 hours each. Coming to the evaluation components, I'll take you to the next slide. So coming to the evaluation components, if you will see this slide is slightly different from what is written in the course handout, right? So give me one working day. I will get the course handout updated with this new information. Now, what is differing is that um uh, the usual one is that we have 2 quizzes which will be open book, and the percentage is 10%, right? So this is the same we have in the course handout, which is uploaded in the eLearn portal. So there will be 2 quizzes, 5 marks each, one before the mid semester and one after the mid semester. You will be notified about the quiz. The quiz will be open for certain duration. So usually it's open for a week, and you can attempt the quiz anytime between, you can attempt the quiz anytime in that week. Okay. My voice breaking? I can see somebody saying voice is breaking. Okay, I'll repeat. There are 2 quizzes, 5 marks each, and one quiz will be before the mid semester, the other quiz will be after mid semester. It's said to be an open book quiz. Each quiz will be open for a week's time, and you can attempt the quiz during that week time, right? Coming to the next component in EC1, which is an assignment. The assignment has a larger weightage this time, so it is 20%, right? So you'll have uh, assignments which will be in the form of case studies, and the total weightage for it is 20%. The target is that you will be given the assignment after the mid-semester, and you will have ample time of say around a month to complete the assignment, and then the evaluation will start. More information on the assignment will be given later, whether it can be group or individual assignment. Mostly the plan is that it would be an group assignment because the number of students is also quite large. How we make the groups, how we proceed ahead, so this will follow up later. But there is a assignment module which will be of 20%. The next two modules, which we called EC2 and EC3, one is mid-semester examination, which is the closed book, and the change here is that its weightage is reduced from 30% to 25%. It's a written examination closed book. EC3, which is an end semester examination, also called as comprehensive examination. It is an open book examination. The weightage is 45%. So again, 5% has been reduced. Earlier it was 50%. Now it has come down to 45%. Again, it is a written examination, open book. You can carry any number of books. You can carry written notes. Whatever material you carry should be properly bound and stapled. No loose material is required, and no loose material is required, and no um, sharing of material is required, and no gadgets are allowed. Okay, e-book on mobiles, Kindle, nothing. Mind you, no gadgets are allowed. Mobiles to be switched off, Kindle, laptop, nothing. Okay, so you have to go with the hard copies of the textbook. Only the hard copies of the textbook, hard copies of notes, uh, printouts of the slides which are properly bound is what is required. Okay, I'm getting question as to where it is conducted. So we have centers across India where the comprehensive examinations are conducted. You need to get in touch with the WILP division. They will provide you more information about the various exam centers that are available where you can go and write the examination, right? Okay, in Delhi, Gurgaon, the center is in Noida, right? No, wait. It used to be in Noida. I think from this semester it's changed. It is somewhere in Delhi, and you need to go and write the examination there. But we have centers in Delhi, Bangalore, Pune, and many cities. You can change the exam center in case you are traveling or you have relocated. All this will be handled by the division itself. So you need to write emails to the person concerned at the division and get this information. Okay, I'll move ahead, and I think in the last half an hour I'll take up all the questions that are there in the chat coming in. It's flooded like anything. Okay, let's move ahead. I'll give you an overview of what is object-oriented analysis and design all about. I'm sure most of you are working, or many of you would be working in this domain, right? In the domain of object designing, right? So many of you uh, would be writing code day in, day out using Java or alternatively C++ in the area of your employment, right? We are not going to look at writing code in this particular course, right? So we'll shift our focus to a step before writing the code. Is that given a problem, how do I identify which are the objects that I would need in this particular case study, how the various objects will interact with each other, right? So I would understand that you are very good coders, but still, uh, it is a sincere request. I would say it's a sincere request that you uh, attend the lecture so that there is always a missing link as to what has to come before you start writing the code, is what is the aim of this course, right? The complete analysis and design of the given case study before you actually start writing the code is what the emphasis for this particular course is, right? A quick overview of what is the object-oriented paradigm. So the object-oriented paradigm aims to identify objects as if they were real-world objects and try to bring them into the software domain. It is completely different from the procedural paradigm, wherein in the procedural paradigm, the emphasis was more on logic and function, right? Whereas in the object-oriented paradigm, the emphasis is more on the data. The logic is there, but it gets encapsulated within the data, which is actually your object. So everything that you have in an OO paradigm is represented in the form of an object. These are the basic building blocks. And the moment we convert something into an object-oriented paradigm, the various important features of the object-oriented paradigm get into that particular design. So it becomes reusable, it becomes extensible, it is modularized, it becomes more maintainable, right? How it becomes reusable? Because my uh, individual objects, they are encapsulating their own attributes and their own methods within themselves. So they start acting as real world objects, and I can pick them up from one place and put them into another. What do you mean by pick them up from one place and put them to another? So I can pick them up from a particular software and put them into another. So this reusability is a very important concept which the object-oriented paradigm brings with itself. It is modularized. My OO design is highly modularized. Every object has a defined function. It does not try to interfere with the functions of the other objects. The aim of every object is very strictly defined, right? It has its own attributes and it has its own behaviors. And that is why we call it encapsulates its data within itself. If any outside entity needs to access this particular object's data, it has to do so only through permissible limits, right? So it is only through the getter and the setter methods or other ways which this particular object uh, gives to the outside world, shows to the outside world, only those ways are allowed uh, to make use of the attributes of this particular object, right? This itself also helps us to make the object-oriented applications more maintainable, right? So if there is an enhancement required in a particular aspect, we know that these are the objects which are responsible for uh, implementation of this particular aspect, or these are the ones which are actually responsible for these aspects, and then we can make changes to those particular objects, right? Uh, uh, The objects, as I've already told you, they are the abstractions of the real world entities into the software. So in this course, given any case study, the first thing is to identify the objects. And the objects that we need to identify always bring along with them their attributes and their behavior, right? So it is very important that whenever we identify an object, we do identify the the state that it encapsulates in it, so that is its attribute. And when we do identify this, it is important that we identify it correctly, as well as the functionality that this object is supposed to carry out. So that is its responsibilities, and its behavior is what is very important, and it should be identified in the correct manner, right? Shared data areas are eliminated, right? So this is very important. When we talk about an object-oriented paradigm, there is no sharing of data in the sense that there is not a common pool where everybody can read data from and write to. So every data is encapsulated in an object. There is data passing between the object uh, as limited by the interface provided by the various objects, right? Along with this, it is also important at the time that we are deciding the objects, it is also important that, say, for these are the behaviors of the particular object, which behaviors are the ones that should be visible to the outside world, and which are the behaviors which should not be visible to the outside world, right? In the first lecture, I'll be talking in more in the sense of an overview, right? But when we get down to subsequent sessions, you would find me using words like whether it should be a private method or should be a public method, right? So this is what actually it means by whether we should go ahead and make this behavior visible to the other objects, or whether it's an internal behavior of the object. This data should be manipulated only in this way by the external objects, whereas the external object should not be able to read or write this particular attribute of this particular object, right? So these are all the aspects which are actually decided at the time we are analyzing a given situation, right? If if we go uh, if we leave these decisions at the time of implementation, that is where it causes a lot of problem, right? And in the object-oriented domain, I should not say in the object-oriented domain, but in the real life, what happens is that there is always an extreme rush to code, right? So whenever we are given a case study, the first thing we do is that open the Eclipse IDE and start creating classes. I know how to write code in Java, and the first thing I'll do is that I will create n number of classes, and I know how this class will be like and how this class will be like, and the first thing we do is write code, right? So that is I would say not 99%, but in fact 90% of the people have this kind of a look about as to how to approach a particular given case, right? And that is what leads to a problem. So there are three things actually uh, through which we should move across, right? So I will move ahead to the two slides ahead. Okay, right? So the path is supposed to be like this. Should start from OOAD analysis, then to the design, and then it should go to the construction of the code, right? So your first box is investigation of the problem, which is object-oriented analysis. The second box tells you the object-oriented design, which is a logical solution. And the third step is your object-oriented programming, which is actually the construction of the code, right? I'll go back to each of these and give you a idea of what exactly is expected to be done in each one of these, right? So your object-oriented analysis aims at investigation of the problem. You are given a problem and you are asked to identify the various real world objects that exist in the given case, right? So the real world objects, the terminology used is domain objects. The whole idea is to identify the domain objects that exist in this particular case study, right? Please be clear, it has nothing to do with the design of the system or the software of the system, right? It is not the software design which the analysis uh, state we are looking at. In the analysis state, we are only looking and trying to find out the real world objects that exist in the given problem domain. And mind you, it's very important to understand what we are doing in the analysis phase, because there is a complete UML diagram which is called the domain model, right? When you are asked to draw a domain model, you have to only identify the domain objects, which are the real world objects. They may translate to software objects, we do not know, that is the second state. But in the domain model, you are expected to carry out an object-oriented analysis of the system and draw the domain model only using the real world objects, right? The problem that I face when the students draw the domain model and give me is that everybody knows how to draw a class diagram, and your domain model is quite close to the class diagram, and the rush is to draw the class diagram. You are not expected to draw the class diagram. Class diagram is the second step, which is the object-oriented design. It is giving you a conceptual solution which comprises of the software objects. There might be certain software objects which are not real-world objects, but which are required to implement the particular solution, right? So these software objects might be the additional objects which are created there, but also there will be the original ones, right? So the real world objects do get changed into the software objects as well, along with the addition of a large number of additional software objects which might be required in order to implement the software as such, right? So it is very important that at this particular time you are able to distinguish between what is analysis and what is design. Design is what actually you people are used to, is drawing a class diagram, identifying the attributes and behaviors of each entity or each object. Whereas in the analysis model, we are just identifying the real world objects. You do not get into identifying the attributes or the methods, right? Whereas in the object-oriented design, there's an identification of the software objects, how they will collaborate with each other, and what is the responsibility of each software object, right? So for example, in a library management system, if I go back, when I'm doing the analysis, the only domain objects that are there is a book and a library, right? The most common ones, right? So given the case study, there might be more, but if I just tell you there's a library information system, the two domain objects that straight away come into your mind is that there are books. So your book is a domain object and there is a library, right? Whereas if you go to the design level, you will identify the attributes the book software object will have, and you will also identify the various methods this will have, right? Your next step is the programming. Programming is implementing the given software design using an object-oriented programming language. And it can be anything. It can be Java, C++, or if there is any other object-oriented programming language that you are aware of, right? It is the last step in which you actually implement the OO design. It is not the first step. But the problem is, because of the extreme rush to code, the first thing that is done is start with the programming, right? You cannot analyze the problem if the requirements are not given. So if the requirements are given, the first step is to analyze the problem, then design the solution once you have an analysis model ready with you, and then go and implement it. Right? So this was an overview of your OOAD paradigm that we will be looking into. So if you see, while we move from the analysis to the design to the construction phase, the book, which is a domain concept, moves from acquiring its attributes as well as methods to a final implementation in an object-oriented programming language. Okay. There was something that was coming into my mind. Okay, we'll move ahead to the next slide. Yes, in this particular course, our more focus would be on using Java, right? So whatever examples that I'll be giving you, of course, that will be later in the design patterns part, but it'll be more focused on using Java. Your textbook T1 also is completely makes use of Java programming language, so it will be good that you also get hold of the language in case you do not, right? So in case you only know C++, it's a good idea to get yourself familiar with Java programming language also. Okay. I think this is what we covered. We'll take up a few questions now, okay, and then I'll also take up what is there in the coming up in the chat. Let's take up this exercise. So when I've spoken so much about OOAD analysis and design, right? Given this question, I would request you to think about the various real-world objects that would be required to model this particular system. So I would just read it. Consider a simple dice game in which a software simulates a player rolling 2 dice, right? The condition is, if the total on the 2 dice is 7, exactly 7, you win, otherwise you lose, right? So you have to design, this is a given case study, you have to design a software for implementing this case study. The first step is to go for an analysis model. I will not go into the model today itself, but let's try and understand if we all are on the same page. So what would be the real world objects that would be required to model this system? Right, you can type in the chat. Okay, so as I can see most of you typing answer as, oh my god, okay. The first one I say there is a player, okay, and the other most common one that everybody is putting, that there is a dice, and then I have Karthik saying me that there is a board, and there is a scoreboard. Okay, and I have somebody telling me, Rolly telling me that I have a calculator. I'll move ahead. Then I have Mr. Chaudhary telling me that there is a game that should be there. Board is a common one, game board. And then I have somebody even telling me something else. So I'll just write this in a different color. So there is player 1, there is player 2, there is dice 1, and there is dice 2. Okay. Okay. I think it's more or less most of you have written this only, and some additional I could see, right? Let's try and understand this. Is there a board somewhere here? Did I even write that? Does the case study even tells if there is a board? The board object that you are saying has come into your mind because of the class diagram that you are so much familiar with, right? Given the case study, given these 3 lines, there is board is nowhere to be seen, right? In this particular case, effectively, if you see, there are only 2 real world objects. There is a dice and there is a player, right? Definitely, when I implement this, I will need a board. Maybe, in case, okay? Do we need a board in this case? Effectively, no. Okay, this is a normal game which is played without a board. So you can just place anywhere, take 2 coins and just roll them on any surface, and you just need to get a total of them, right? So the concept of board is effectively gone, right? So board is not there. Is the scoreboard there? Right? If I have to implement this and provide a design of this particular case study, the scoreboard will be there. But it is not a real world object. So when you are only identifying the real world objects, your scoreboard is not there. Do I have a calculator? Does it anywhere says I need a calculator? No, I even don't have a calculator. There is no need of a calculator or a scoreboard, nor do I need a game. I would probably need all these software classes to implement my system, and I will incorporate these software classes only when I will design the solution. When you're carrying out an analysis of the system, you only need to identify the real world objects. We convert the real world objects into software objects and then add additional objects that may be required. Right? Now coming to this, somebody has said we need the real world objects are player 1, player 2, dice 1, dice 2. No. You are correct in identifying that there are 2 types of objects. There are 2 types of domain concepts, player and dice, right? Their instantiation in real time in terms of objects as to player 1 and player 2 is a completely implementation based issue, right? Whether we make 2 instances of the player object or the player domain concept, or we make n instances of the player domain concept, that is at the implementation level. Right? So you are correct in identifying that there is a player domain concept and there's a dice domain concept, but how many instances of each would be there is not the point of concern during the analysis model. Right? I hope I made myself clear and I could find most of you getting the correct answer. Okay, I see people typing, we need a scoreboard. Definitely you need a scoreboard, but when you are analyzing the solution and given the context, right, it is very important that given the context, you should stick to the context and then find out which are the domain concepts that you would require. I do not say you will not need a scoreboard. You will definitely need a scoreboard, but that is a software object. That is not a domain concept, right? So I would like to type out this word. This is called as domain concept, which is our point of concern in the analysis model, right? And then alternatively, there is something called as a software concept which comes up in the design model, right? And here is where your scoreboard and calculator will everything will come in, right? So you need to strictly be able to distinguish between the analysis model and the design model, right? Okay, I'll move on to the next question that I have. So, okay, wait. So the real world objects in this case are the dice and the player. Let's take the second one. Okay, this is a step enhancement to the previous one. So consider this simple snakes and ladders game wherein two players take turns to roll a dice and move their coins on the board. The player whose coin crosses the 100th mark first is the winner, right? It's a normal snakes and ladders game. Now in this case, you have to identify the real world objects. Okay, you can type in the chat and we can move ahead and discuss. What will be the real world objects in this case? Okay, I'm unable to get responses. Are there people saying, okay, I get something. So there are people saying dice. Okay, so I type in here. Oh, wait, it's not coming. Okay, so there is dice. So we know it from the previous one. There is coin. Okay, and there is a player. Seems some problem in scrolling to the chat. Okay, so there is someone who's added two more domain concepts. So you have snakes and ladders, and there's a boat. Okay. Okay, I think that's it. Everybody is adding, right? Uh, so in this case, I hope dice is fine with everybody, right? So it's like the previous one. So we have a dice which the players are rolling, and of course the player is one domain concept we'll definitely have in this, and of course we have the coin, right? So all these three are fine, right? Now coming to the next three. Uh, we'll talk about snakes and ladders later. Do we need a boat? Okay. So in my snakes and ladders, if you see, I have a board which has snakes and ladders placed on the boards, right? And it's a static board, fine. And every snake uh, has a tail and a mouth. Whenever you land on a tail, no, whenever you land on a mouth, you fall down to the tail, location of the tail, and whenever you land onto the ladder, if it's a climbing ladder, right? So if you are at the starting point of the ladder, you climb up the ladder, right? This is how it's played. So definitely, board is a domain concept here that is required, right? Do we need domain concepts like snakes and ladders? This is what the question is. Okay, we're okay with dice, we're okay with coin, we're okay with players, and we're okay with board also, right? Because we definitely need a board, which is a static board in this case, and we know that we'll move across, the coins will move on the board, right? And it is if the coin of a player crosses the 100th mark, then we know that this player has won the game, right? So we definitely need a board. The question is, do we need snakes and ladders? Are the snakes and ladders the real world objects or domain objects in this case? Right? The answer for this case is no. Right? Now this even answers one question which is going on in the chat, which says that we have been told that all nouns are domain objects. Right? All nouns are real world objects. So if we see this question, there are snakes as well as there are ladders, which are nouns, and they, according to that, they do fall in the category of domain concepts, right? But if this question is given, your snakes and ladders, although being noun, are not the considered domain concepts, right? My board in this case is static, right? I need not have a domain concept which is like snake or ladder, right? It's a static constant board. All I need in that board is a relationship between the various coins, the various positions of the board with the other, right? So instead of programming the board in the form of a snakes and ladders, you can conveniently program the board in the form of either a linked list or have pointers to the other location. So it's say it's a 100 by 100 array, right? And every location in my array can store a number of pointers. And then there could be directions with the pointer. So either it is going, it's a forward pointer, it's a backward pointer. So if it's a forward pointer, I know I'm landed on a ladder. And if it's a backward pointer, I know I've landed on a snake, and then I need to get down to the snake, right? So at this particular time, if you analyze this particular question, your snakes and ladders, although being nouns, they do not exhibit any special attribute or behavior so that they may be considered as an important domain concept. Right? Now here you will tell me that when you are identifying the domain concepts, you are also talking in terms of implementation, right? That's an obvious question that will come. Because when I'm saying I will implement the board in the form of an array and I can as well as pointers, right? And then why should I need snakes and ladders? I don't need it in this case to be as the domain objects, right? That kind of a question is very right, right? But the answer to this is that in this particular case, I know that snakes and ladders do not possess any special behavior or do not possess any special attribute that I would, because of which I need to put them as real world objects.